This is the mission for cybersecurity information challenge. In cybersecurity domain, the problem statement focuses on an AI-assisted log investigation framework. Currently, in incident response, there is massive amount of data coming from various devices, such as IoT device, server, mobile endpoints. For normal user, it is very difficult to parse these data and correlate them effectively. This increases the mean time to detect and mean time to response. The core problems are fragmentation of data in spread across various places and difficult to correlate. Handling gigabytes of data is not easy. Furthermore, the current solution adds a barrier for normal user. The proposed solution is a web-based forensic coordination layer where AI and ML are integrated. User can simply drag drop files, whether they are Windows event log, Android loggate, syslog, CSV or JSON. System handles the rest. Here you can see the file is dropped and parsed immediately. The parsed file now is JSON format, enters in a layer of normalization. Normalization basically means separating event IDs, messages and IPs so that ML scoring can work over it. The system utilizes an isolation forest algorithm to take each line of the CSV and add an inference score to it. The score is then sent back to original data, creating new dataset where ML score are attached to every single line. Now, these data set with ML score is then sent to a comparator. If the scores are more than threshold, it is sent to LLM in cluster, while if the score is less, it is removed as noise. After this stage is completed, the LLM reconstructs the whole story. It does two things. First, it provides a page to list and read all the correlated data. Second, it generates LaTeX-based code which is sent to the LaTeX compiler, which is integrated in the system, allowing users to edit the PDF report and see the preview instantly. Finally, there is an export area to download the pre-made report or export the raw data in CSV or JSON format with the ML score included. Now, going to technical approach. Before that, I would like to show you our website where you can just upload the log data, choose your file. Here, this is the bots version 3 file from Splunk database. We'll upload it here and analyze this. This file contains real data and used in various TTF challenges. A specific part of it was taken to demonstrate the platform. After uploading the file, the parser can be seen working perfectly. After parsing, the system receives all the necessary details, including timestamp, event IDs, sources, activation result, detailed attribute, etc. All of this is included in the processed CSV. Searches can now be made over event IDs, which you can see, or over an IP address, or you can filter it out using the threshold scores. Moving to the analytical dashboard, where you can see a spike, which usually indicate brute force action. The dashboard also displays threat distribution and user distribution. It also lists the top IPs and detected anomalies. Moving on to attack story feature, where you can paste your API key, which we need to generate from the Google. The LLM takes the filter data and create a narrative story based on threshold values, specifically the value that indicate high risk. After this analysis, the report is generated. This report is in LaTeX code, which can be edited to your needs. As the compiler works perfectly, if I recompile this, you can see the changes in live view. You can download the report from this download button here. Now, coming back to our write-up, I have already explained ingestion and parsing. Now, how the confidence scoring works. In the ingestion phase, the raw file goes into node.js backend, where the parsing service detects the log type and normalize it. Now, how the confidence scoring works. The ML model uses isolation model and other indicators which are based on severity type, event type, frequency and pattern, context In correlation with all that, the ML scores are added to our dataset. The data with the ML score are correlated and clustered to detect and form a story, and then it is visualized in our front end. The expected outcome is drastic reduction in investigation time. For normal user, a single pane view can help them detect and act upon their data. The AI is accessible. Even junior analysts can work over it and perform their task in a much faster manner. In the end, the user will also get a standardized reporting which can be formatted using latex code to their own needs. Benchmarking and differentiation. Current tools work like a search engine where data is manually searched across each of the lines, whereas in this framework, data is automatically reconstructed. The ML score helps you to filter out those data and remove that high volume, which do create the bottleneck. The previous systems, or also most of the current system, require knowledge of SQL, regex, or their own query-based languages. Whereas in this framework, you do not require those skills. This is searched using more of a natural language based. The final story in previous system have a lot of data which you need to correlate and work upon yourself, whereas here the complete story is provided. Bridging the forensic gap. Most cybersecurity investigators relies on centralized aggregation of or manual parsing, which is good for compliance but leaves a forensic gap. The solution bridges that gap by eliminating syntax barrier and using prioritized by design. Traditional workflow force analysts to scroll through thousands of chronological entries. This tool reduces that drastically. It moves from raw data to a narrative, creating a story that helps the normal user understand exact what happened to their systems. Now, the product roadmap. Phase 1, which is the current stage, where full log ingestion, meaning the parsing is completely working, any type of log can be dropped, ML confidence scoring is working, and a tag story is being created using Gemini or LLM integration. Now, phase 2 will involve the secure database storage with chain of custody hashing, allowing the system to accept multiple log upload where it can correlate data like similar IP across multiple devices and can flag them. Also, integration with local LLM like Tiny Llama. Phase 3 will be about scale, integrating with SOA platform using our modular Node.js architecture to allow for easy cloud deployment. To wrap up with a use case, an investigator uploads Windows or Android log files via the drag and drop interface. The platform automatically parses and normalizes the log, applies confidence scoring, and correlates high-risk events. These prioritized events are synchronized into an explainable attack timeline, enabling rapid understanding of the incident and generating a structured forensic report.